Hello Internet, welcome back to the workshop. In today's video, we're going to continue work on the surface grinder. Specifically, I want to show you how I repaired the worn out shaft and drivetrain for the work table. It works like new now. If that interests you, stay tuned. We'll get started. In the previous video, in part 3, I made a new shaft and a new bushing and repaired the main drive gear. In this video, we're going to focus specifically on the drive shaft and the smaller gear. So the way this table works, the x-axis moves back and forth and it's controlled by a set of gears. As this smaller gear sits in 2 bearings and rides on this shaft, and it has worn it down considerably. Hopefully you can hear how much wear there is. I measured the shaft and it's most worn right here, and it measures 748 on the 2 ends and it's down to 718, so there's 30 thousandths of an inch wear. So I am going to turn it down to that 718 for the entire length. Because of the way that gear rode on it, this keyway is thicker, or is wider from here to here than everywhere else. So I'm going to use the mill and a really tiny bit, and I'm just going to clean that up. Now that we've got the shaft sorted out, I want to turn my attention to the gear. I want to take this gear, I want to remove these guides, bore it out, and press in an insert. I'll get you a better view here, but you can see how worn these are. They should be square, and you can see they're quite T-shaped. And that's because they've worn down over time, because this thing moves and rotates that shaft. And so as it's worn or developed slop, these have taken the abuse. So we'll need to make new ones of these, but we'll do that after I push in the new bushing. Because it was so sloppy, it ran along this steel bushing and it's worn a groove into the end. So the end is no longer flat, it's become concave. So I'm going to try, and I don't know if this is going to work, but I'm going to try and use a carbide end mill in the drill press milling machine and see if I can just mill this flat. I ran this on the wire wheel just to clean it up so that when I grab it with the chuck here, I know I'm centered. But that milled surface cleaned up just fine. I'm probably going to leave it just the way it is. So I'm going to chuck this up in the lathe here, and I'm going to face this side. And that should give me 2 good flat sides to interface with the new bushings. That looks pretty good. The new bushing has an outer diameter of 7/8 of an inch, so it needs to be bored out to accommodate that. The new gear bushing needs to be bored out so it'll fit the new outer diameter of the shaft. Here's a better look at the bushing we're making for the gear. It's a bronze bushing with 2 slots cut in for keys. Those keys will be modified to fit in the slots and they'll ride along the keyways when the gear is moved. So initially there were 2 steel bushings pressed in here, and both of them have worn into egg shapes. They're completely trashed. So I'm going to replace those with a pair of bronze bushings. I'm using some 5/8 ID thrust bushings, and I'm going to bore those out to fit the shaft. So now that I have these turned down on the ID, I need to cut them down so the thrust thickness is what I need for this gear. And so when I take that gear, it fits in the table like so. And what I want to point out is that the thickness between the two, or the distance between the gear and the 2 bosses here, are not the same. So I will have to turn one thrust bushing down more than the other. The last thing to do to these bushings is drill the oil holes. The oil supply holes for these, they come in at an angle and they come out right about here. So when I press these in, I want that oil hole that I just drilled to line up with that so that the oil will flow down through and into these bushings. Alright, there's one side. Let's do the other one. Alright, that's 2. Let's see if the gear fits. Where the gear fits between them. And then this, ooh, it's a little tight. Doesn't quite fit. I'm gonna just take a little bit more off the gear. It fits, but it's in there so tight that it wouldn't be practical to use it. I decided that instead of removing material from the gear, I would just press this out and redo it. So I pressed it out and I took a little more off the face. And now that gear fits in there just absolutely beautifully. Shaft is a little stiff. So here's the bushing I made, and these are the keys, and I've numbered them because they go in specific spots. So these keys have a slight T shape to them. They go into the bore from the inside, so the smaller side of the T goes into the slot, and then that can now slide onto the shaft, and then the new gear, or the gear that I bored out, will press on, and these tabs will fit into the slots that are already on the gear. That looks really good. So this is now too long because I had to turn this gear down. So I'm going to put it back in the lathe and I'm going to turn down this bronze bushing just so it's the same width. There we go. It's a little tight, but check that out. Let's put some oil in there. So here's how it turned out. Everything works really well. The gears now rotate perpendicular to their axis. There's no free play and no wobble in those gears like there was before. The drive shaft moves up and down freely. Before it had probably a 1/4 inch of movement on the far end. Now there's almost no movement, no free play. So I'm really happy with how this turned out. When I pulled it apart and I saw that wear, I didn't really know how I was going to fix it. And this is almost as good as new. Once it's back on the table, it's going to work it's going to work really nicely. So I hope you enjoyed watching this video. I had fun with this one. I really enjoy it when things work out better than I think they will. So I appreciate you all taking the time to watch this. I hope you enjoyed. If you did, would you consider subscribing? Very much appreciated. So with that, guys, thanks for watching.